Okay, so now our actor's event graph is looking nice and organized. It's got lots of comments, and thanks to these comment sections, we can click and drag around entire sections of our blueprint logic and not have to worry about highlighting them. And so that's actually very useful. And so we're going to try to keep our stuff organized like this as we create our blueprint nodes. And in fact, something like this over here, it's a little bit messy, and I kind of like to have things organized a little bit better than this. And so what you can do if you want to is just, take a few minutes to take as much space as you need here in the event graph, because really there's a lot of room here. So you're not going to run out of space. And just make sure that things are not bunched up, and give yourself plenty of room here to work and just drag things out, and just organize as much as you see fit so that things look good. And in fact, take advantage of reroute nodes. So I'm going to double click this here and make sure that these wires are not passing behind other wires and things like that. You can have multiple reroute nodes on a single wire, and also take advantage of, again, comments and things like that. So if I highlight these and hit C, I can comment this and say emitter 1 and things like that. So yeah, I would say, take a few moments to organize things, make them look good, and that way, when you come back to it later, you'll understand what it is that you are looking at. And sometimes with big projects, you'll come back after weeks or months and you'll forget everything about what you did, and so it might actually look like a bunch of gibberish. But if you have comments and sections and things are labeled properly, that won't be the case. You'll know exactly what you're looking at. You'll say, oh, this is the second emitter, this is the third emitter, and so these comments are going to save you later on. So that looks nice and good. Okay, so now that we've covered those, I would like to introduce you to a few different new types of nodes, and let's go ahead and expand our arsenal and our capabilities as game creators. So I'm going to go ahead and compile and save my actor and close it out. And now what I'd like to do is take a look at our rolling ball. So let's click here on the ball here, and you'll see that it's got quite a few things. And as soon as you've clicked on it, you got this red line, and you look up and it's connected to a camera. That's the camera that you switch to. That's the view that we switch to when we hit play. So now we're attached to this camera that's looking down at the ball, and it's following the ball around in the world. That's that camera that you're looking at up here in the air. And when you select the ball, you see this red line connecting it. Now, in a future video, we're going to create this whole ball system from scratch, and we're going to learn just what that red line is, and we're going to learn more about the camera. But for now, just to introduce you to more nodes and more things to get you more capable, we're just going to take a look at the blueprint for this. And to do that, with the ball selected, we'll see over here in the world outliner, we renamed it the ball. If I right click on it and I click browse to asset, you'll see that it takes us to this folder here. It's in rolling BP, in blueprints, and we have physics ball BP, and it's also next to another thing called a game mode, and we're going to get to what those are very, very soon. But for now, take a look at physics ball BP and double click on it, and you'll see that we open up this blueprint. Now again, we used a ball roll template, so this was all created for us already. And take a look, it's got already some logic programmed in here, and whoever made this made good use of comments, so each one is in its own comment section and they're labeled accordingly. So this looks all really good. Now again, I said we're going to create this ball character guy from scratch, and so we're going to actually do all of this from scratch ourselves in a future video. But for now, we can just use it, and we can add additional functionality on top of this. And so what I'd like to do is come over here to the side where we have some extra room, and I'm going to right click, and I'm going to hit something like, say, the O key. And if you hit the O key, you'll see that there are some options here corresponding to just an individual letter, and those are for that particular key. It says events for when the O key is pressed or released. So if you click on the O key and you zoom in on it, you'll see that we get this node, and it's got a pressed and a released output execution pin. This is for when you press or release the O key. And so let's just see how this works by dragging off of the pressed and get our old handy dandy print string. And for the message, let's say O key pressed. And of course, I'm hitting all these different keys on my keyboard. There we go, O key pressed. And I'm going to Control W to duplicate it and drag in the released execution pin. And instead of pressed, let's say released. And so we can come back. Let's dock this back up to the top here. And let's see how this works. So let's hit play. We'll click in the editor and hit the O key and release the O key. Hit it, release it, hit it, release it. And you'll see that we can do this multiple times. And basically, that is one easy way to map some functionality to a key press. And so you can do that for any of the keys on the keyboard. And so this can be a very useful thing to do. So since we are using the O key pressed and released, we would like to do something a little bit more interesting than printing a string. And so I'm going to introduce you to some more new nodes. Now, one interesting node that I'd like to show you is a node that will get anything that's overlapping with this particular actor at any given time. In fact, it's more for a individual component. So you can have a component here that may be overlapping with something. Now the ball is set to collide with things and not really overlap. So I want to add a sphere component that can overlap with things. So let's go to Add Component, type in Sphere, and let's get our sphere collision. And we can leave its name as sphere, that's fine. And over here in shape sphere radius, I'm going to drag to the right, and so that way we can make this sphere a bit bigger. I'm going to drag it up to about there, 295. In fact, I'll just go ahead and set that equal to 300 and make it an even 300. And I'm going to come down here to rendering and uncheck hidden in game, and that way we can see it in the game. So if we go back to the level in the viewport, you'll see that we can actually see this sphere, and this sphere is just going to follow us around because it's attached to the spring arm. And in fact, what I'd really like to attach it to is the ball. So since it's attached to the spring arm, I'm going to click and drag it on top of the spring arm. Oh, I guess it wasn't attached to the spring arm, so I'm going to undo that. It looks like it's actually just attached to the root. So I think that's fine. It looked like it was indented, but that's just because we have an arrow here. So it's not actually indented. It's only attached to the root. So that's fine. So it's gonna follow our ball around. And so if we hit play, and it looks like I don't see the sphere component. So let's see. Let me take it and drag it onto interesting. It's not showing up. I'm going to close out a physics ball, open it up. Okay, I see what happened. So it looks like the location has been changed a bit. And so I'm going to go ahead and take the location and hit 0, 0, 0 and bring it back down to the origin of our ball component here. So if I come back in here, it's back to where it was, and it's following our ball around. So that looks good. So because it's attached to the root, you'll see that it actually moves along with the root, and it's actually rotating along with the ball's rotation because the ball itself is the root. You may have noticed that right off the bat that the root component is the ball. That's the ball mesh component. So it's because sphere is attached to the ball, it actually changes its location and its rotation along with the ball. So that's all good. So since we have a sphere collision volume here, I'm going to introduce you to that special node that I was talking about. So it's called get overlapping actors. So if I drag off sphere and bring it in, and I drag off of sphere and I type get overlapping actors, you can get overlapping actors and overlapping components. So I'm just going to get overlapping actors. And you have a class filter here. So if you leave that blank, what this does is it gets all overlapping actors that are overlapping with this sphere component. And what it does is it returns you an array of those actors. So basically an array is a collection of actors, at least if it's an array of type actor. And so what do we do with this? What can we, how can we use this? And I'm going to show you a special type of node that is used for arrays. And by the way, notice that you don't get a little blue ring here. Instead of a ring, you get this symbol that is what you get for arrays. It's basically a bunch of little squares, and that's for an array. And so what we do is when we drag off of this, if we type in for each, you'll see that we have a node called for each loop, and you'll see here that it takes an array. And so if you drag in an array here, then the for each loop will loop through that array, and for each one of those elements in the array, it will do something, and that something is whatever you hook up to the loop body here. And so we're gonna see exactly what this does, because when we loop through the array element, this is the item in that array at that particular iteration. And so if we drag off of array element, what this should be is basically an actor, one of the actors in the array. And from the actor, if we drag off, there's a nice node called get name, and that if you click get object name, then this return value is a string, and we can actually print this string to the screen. So if we call print string and we hook up this loop body, we're going to see that what this does is we get overlapping actors, which gets any actor that happens to be overlapping with the sphere at the time that this was called, and then for each will loop through all of those actors. And for each one of those, it'll do something. And what it does is it gets that actor's name, and then it prints that name to the screen. So if we come in here and hit play, we click in, and let's go and overlap with a couple of actors, like this bunch of boxes here. And then let's just hit the O key, and you'll see that we're only printing the ball. So in fact, this node that got all overlapping actors actually didn't get these boxes. And the reason is because if we go in and click and select one of these boxes, and we go down to its collision section here, you'll see that generate overlap events is not checked. So if we have a box selected and we click generate overlap events and we have that selected, now if we hit play and we come over to the objects and hit the O key, now because that one cube was set to generate overlap events, it actually is acknowledged because it actually overlaps with the sphere. And now when we call get overlapping actors, that cube is included. So we can actually come down here and we can select all of the other actors. So I'm selecting one, holding shift and selecting the other ones, and we can go down into the collision section and click generate overlap events, and that will check generate overlap events for each of these individually because they were all selected. Okay, so since that should work for all of them now, we can hit play and we can come over here and overlap with all of them and then hit the O key, and now we're looping through that array, and because they're all generating overlap events, we're getting all of them and we're printing their names to the screen. So that's what for each does. It takes an array, so I'm going to hold Alt and disconnect that. So you'll see that it takes an array of actor object references, and get overlapping actors returns just that, an array of actor object references. It's basically a collection of a bunch of different actors. And so this will get all overlapping actors as long as they have overlapping events set to actually happen. So we had to go in, select them, and check the checkbox for generating overlap events right here. So as long as any actor has that selected, it will participate in this get overlapping actors. So that's great. That's an excellent way to get all actors that are overlapping with a particular component, in this case, a sphere. Now, this class filter is an interesting thing. What it can do is it can filter out and ignore any other types of actors that you don't want to include. Or in fact, what it'll only do is include actors that are based off of the class that you choose. So if I type static mesh actor, then the only thing that will participate in this is static mesh actors, as long as they have overlap events set to actually work. So we can come over here, and these will work because they are static mesh actors. But notice that the ball is no longer being printed because the ball is not a static mesh actor. It's actually a physics ball BP. And so this filter is leaving the ball out of it. So if we reset this and set it back to none, and we come back and hit play, then when we hit O, you'll see that the ball actually is included in that. So the ball, and along with the other cubes and everything. So the ball will participate, but if we set this filter to only static mesh actors, then of course the ball is no longer included in that and is ignored. So that is how this class filter works. So that's all great. So now that we know how to get all overlapping actors with our sphere component, and we also know how to loop through them and do something to each one of them, what do we want to do to each one of them? Well, I would like to do something more dynamic and more exciting. How about if we overlap with a box and we hit the O key? What if we create a sort of explosion-like effect and send them flying off into the distance? Wouldn't that be interesting? And we can actually do that with a very special type of node called add radial impulse. So if we right click over here and type add radial impulse, you'll see that add radial impulse is a specific function that takes an individual object. So you can add radial impulse to the ball, you can add radial impulse to the sphere, and so on. But if you uncheck context sensitive, you'll just see that it's add radial impulse. We can select that, and it doesn't have a target set to it. And by default it's self, but I don't want to add a radial impulse to the physics ball BP. I want to add a radial impulse to each of the elements in this array, each of the overlapping actors. In other words, the boxes that we're overlapping with. And so here's what I'm going to do is, instead of printing the name, I'm going to delete get object name and print string. I'm going to bring add radial impulse over here, and the array element, I'm going to drag that in. Actually, the array element needs to be compatible with primitive component object reference. So instead of array element, what I'm going to do is drag out, and I'm going to cast to static mesh actor. And as soon as we cast to static mesh actor, then as static mesh actor, we can't drag in static mesh actor, but you'll see that it automatically will get the static mesh component from that static mesh actor if we drag it in. Because remember, a static mesh actor is an actor, and actors contain components inside of them. And for a static mesh actor, it contains a static mesh component. And so that is what we need to add radial impulse to, is the static mesh component for each static mesh actor. So I'm going to drag that in. And for the origin of the add radial impulse, what add radial impulse does is, if we go back in the map and just take a look at our ball, we want to create a radial impulse which basically will cause forces to be affected on the static meshes that are overlapping with our sphere and cause them to fly away. And radial is talking about basically having a force affect things depending on how close they are to the origin of the radial impulse. So if I make the origin of our radial impulse basically the origin of the ball actor, in other words, I just use get actor location, and take this get actor location node and plug it into the origin for the radial impulse, then what will happen is a force will be applied to whatever's being passed in to add radial impulse, and that force will vary depending on that object's distance from the origin of the radial impulse. And so the radial impulse will have a radius of basically how close to the origin of the impulse you need to be affected by it. And so we can have a radius, and we can choose that to be something like 250, or we can alter it and see how that affects things. And then we have a strength, and the strength is basically how strong the impulse should be. So if we set that to 100, we can see just how it works when we test this out. Now, velocity change is basically something you can turn on or off. Now, when it's turned off, then the impulse will be calculated on the object based on the object's mass. And so the impulse will have a particular strength, but the mass of the object will affect it. So the heavier the object, the less dramatic the impulse will be. But with velocity change, you will ignore the object's mass, and the impulse will react the same to that object as if its mass were not a part of the equation. So we're going to see how it works with and without velocity change. So for now, click velocity change, get that checked. We'll have a radius of 250, a strength of 100, and so again, what this does is as soon as we hit the O key, we get all overlapping actors with our sphere. We filter out everything but static mesh actors. And then we do a loop with a for each loop, which basically loops through all those actors that are overlapping with us. And for our loop body, we're going to make sure this is connected, otherwise it won't work. We're going to use this array element, which gets us the value of the particular element that we're looping through. Remember, this is the same as going through each actor one by one, and array element gives us the value of that actor for each time. So for each one, we're going to cast it to a static mesh actor. We're going to use the static mesh actor's static mesh component to call add radial impulse. Now the origin of that radial impulse is going to be the location of our ball actor, basically the location of the root component. And the radius of that radial impulse will be 250, the strength will be 100, and the velocity change checked means we're going to ignore the mass of those objects. So let's just see how this works. Let's go back and hit play, and we'll go over here and overlap with these static meshes and hit the O key. And you may have noticed that it barely adds an impulse to those objects. Like if you keep hitting O, you'll see it's barely adding a tiny bit of force to those objects as long as they're within the radius. Now what we can do is, first of all, we can take the strength, and instead of 100 we can bump it up to 1000, and that way if we come back and we hit play and we come over here and hit the O key, now there's a little bit more of a force. It's more noticeable now that the strength is higher. Now notice something else. If objects are farther away, even though they are overlapping, for example, these two boxes here are overlapping, but because they're farther away, they're not really being affected by much. That has to do with the radius here. So if we take this radius and bump it up to 500 instead of 250, now we can come over here and we can get close, and now things that are even farther away, as long as they're still overlapping with that sphere, they will be affected. So when that radius was only 250, if those objects were not at least within that radius, they weren't affected. Now they're affected even if they're within, they have to be within the radius of 500. So if they're 500 units away, they'll still be affected. Now notice if I get up close, then it gives us a nice, pretty strong impulse. If I get really close to the box, it'll shove it away. But if I get kind of far away, just barely up to it, just barely inside of the overlap sphere, then we still get a force, but it's not quite as strong.